Hi, and welcome to another edition of ASCE Interchange Live. I'm your host, John Marston, Associate Editor for the American Society of Civil Engineers. Thanks for joining me today for a discussion on how civil engineers are building stronger communities through disaster resilient housing. My guest today is Lizzie Collins, Chief of Engineering and Chief Administrative Officer of Build Change, a global expert in disaster resilient housing. Welcome, Lizzie.
Thanks, John. It's great to be here. I really appreciate the opportunity to talk more about disaster resilient housing and Build Change's work.
Great. Well, we're glad you're with us today. The US Census Bureau says 2.5 million people were displaced last year due to extreme weather events, such as tornadoes, wildfires, and hurricanes. As natural disasters become more frequent and severe around the world, people and their houses are becoming more vulnerable than ever before. So, first, who or which areas are most vulnerable to displacement and other adverse effects of extreme weather?
Great. Yeah, thanks, John. We know that many people are exposed to extreme weather and other natural hazards. The World Bank estimates that more than half of the global population are likely to experience an extreme weather event. But when we talk about vulnerability, considering how significantly people are adversely affected by the extreme weather, the most vulnerable are those with less resources for mitigating the impact of, or adapting to, or coping with the impact of disasters. And those with less money, with fewer social protections, less access to financial services, or those who are more likely to lose their livelihoods due to extreme weather are really the most vulnerable. These shocks can destroy a key asset like a home or a livelihood, and this may not be recovered immediately and can even have negative impacts for generations. We also know that overall, women and children are 14 times more likely than men to die in the event of a disaster. So there's also a gender-related aspect to who the most vulnerable are to these adverse effects.
Wow.
Yeah.
You've spoken at the real local personal level. Now, how do these disasters affect economies on a national scale and a global scale?
Yeah, definitely at the household level, these disasters can be devastating, for generations, like I mentioned. But, at the national level and the global level, there's also a big toll. First, of course, the unfortunate potential casualties, injuries, and deaths, this cannot be overstated. Protecting and safeguarding life regionally, nationally, globally is paramount. Second, these events can divert important resources. It's way more cost effective to mitigate before a disaster than to try to repair and recover after the event or damage has occurred. We also, I guess, thirdly, the displacement, can really lead to changes in available workforce. It can create ghost cities, which in turn can impact the economy and GDP. There are really, so many other factors and impacts, of course, on farming, on infrastructure, on health, and these all add up to really negatively impact the economy at scale. In fact, the World Meteorological Organization, excuse me, estimated that globally there were, I think, $1.5 trillion in economic losses due to extreme weather in the decade leading up to 2019 alone. So, this is obviously a huge effect. And some countries around the world are more at risk too. For example, at Build Change, we've been working with some small island developing states who are particularly concerned about resilience, given their level of risk and the impact that they could have. As an example, when Hurricane Maria struck the island of Dominica back in 2017, the total damages were around 224% of the country's GDP. So a huge impact there. But we also know on the flip side that better housing can have a positive effect on the economy. It's been reported that equitable access to adequate housing and informal settlements can actually stimulate the economy, um, with more than 10% economic growth at the national level. So there is two sides to this as well.
Yeah, there's the loss and there's the positive on the flip side done right. Yeah. Now, what are the most important considerations in designing and building disaster resilient homes themselves and communities?
Yeah, there's definitely a lot of considerations. At Build Change, we kind of put things into three categories. What we found to really be the three main barriers that must be addressed in order to achieve change in housing resilience at scale. And these three categories are people and policy, money, and technology. And if we think about it in those terms, we can really accelerate, access at scale. So on the people and policy side, it's, what are the norms, what are the preferences that need to be integrated into these designs, into these solutions? How can people be actively engaged in the process, to increase their understanding of the improvements or of the new methods that are being used to make their homes more disaster resilient? And how can the improvements, for disaster resilience, not just improve maybe the disaster resilience of the home, but also overall improve the quality of life and living environment for the people in the home? And what policies, are in place to help enforce and enable these more resilient housing standards and practices? So that's sort of, one bucket that needs to be looked at. And then on the money side, if people can't afford to build more disaster resilient houses, they won't. So how can, resilience be improved in a way that is affordable? A lot of times improving an existing house will be more cost effective than building a new one. um, and are there financial resources or programs that can be leveraged to help offset the cost of these improvements? This could be subsidized, access to subsidies or insurance discounts or other programs that often are available, but people may not know about. And then it's also interesting that oftentimes small improvements or tweaks can have an impact, but they can also be more affordable than adopting totally new technology. So definitely understanding the financial capacity of the owner to be able to absorb one option or the other is important. And then when we think about the technology side of things, are all applicable hazards being considered in the design? Can anticipated future increases in hazard levels be accommodated easily or not? Is the construction technology well known, or will specialized services, and expertise be required? Is the workforce well equipped, to construct this to the right level of quality, or is training and upskilling required? So these are all, you know, I guess, questions that need to be answered when you're thinking about, the design for more resilient housing.
Oh, for sure. Especially when you're talking about like impoverished areas that seem to be in the most direct path, often happens to be.
Hmm.
Yeah. Now, what are the most exciting innovations or promising innovations and technologies that are already being implemented in building these disaster resilient homes? Or what kind of things are being can be ramped up and applied at scale?
Yeah, well, I definitely think that digital technology has a big role to help reach scale. So it can be used in the planning and design phases and construction supervision phases. We've developed our own Build Change technical assistance platform, BC Tap, that helps to kind of streamline the full project lifecycle from assessment and planning to design to financing to construction and reporting. It really brings together technical and project management expertise in a sort of digital workflow that really helps generate scale. And I think there's a lot of opportunity with technology to do this and to make things more accessible. There's also AI, which is a really hot topic right now, and I think really we're kind of in the early phases of really understanding and exploring how that can accelerate and support resilient housing. We've, been using AI. Back in 2018, we actually developed an AI application that helps screen houses after the 2015 earthquake in Nepal to understand, is this house a good candidate for retrofitting or not? So sometimes, making those decisions and triaging the needs is a good way to use AI. We've also developed simple construction quality assurance checks, using AI and image recognition. And I think there's really a lot more that can be developed with these new technologies to further increase access. Of course, then there's also new building and construction products that are always evolving and can make the job easier. And there are a lot of great options out there, from innovative materials to smart technologies for homes, really depending on what the budget available is, from the homeowner, from the developer. But, to be honest, generally I get more excited about some of the simple, cost-effective, well-known technologies when it comes to construction that are easy for people to use and adopt. I think that's really where the opportunity for increasing resilience at scale is. So, for example, using hurricane straps, making sure the nailing is correct, having tie downs in walls. These are all proven technologies that are also key components for wind resistance. And a lot of homes, particularly older homes, may be lacking them, and so adding those in and really improving the resilience of the home that way.
Makes sense. Now, should civil engineers consider building more disaster resilient homes even in areas that are not typically affected? And what would be the considerations that would go into that?
Yeah, I mean, I think in some cases this may be applicable. We've all read about how flooding, fires, heat stress, windstorms are growing, not just in intensity, but also, perhaps in geographical reach. And so, I think that if there are sort of low cost or no cost ways to integrate more resilient construction techniques, then why not? But it's really something that I think could be discussed and weighed, with the homeowner, and with some rational approaches to, what what makes sense and what may not, be applicable. But I think this is also an area where there's an opportunity for the regulators, to provide some guidance, in terms of what should we be looking forward to in the future, and for the profession to make some consensus recommendations. Of course, as a starting point, making sure to follow the most up-to-date standards and practices, even if maybe they're not yet adopted by the local jurisdiction, could be one way to really be forward-looking in that respect.
Mhm. Just seems prudent,
Yeah.
Yeah. Now, what can be done to help a community recover from a natural disaster? And how can civil engineers during the recovery better prepare those areas for future events?
Yeah, yeah, no, I mean, I think to answer both those questions, or maybe bring them together, I think the
Hey,
best way to help is to prepare, through mitigating the risk beforehand. There aren't really natural disasters, just, really man made ones. But in turn, then the solutions are there to prevent and mitigate them. But in any case, after a disaster has occurred, communities do need immediate support. They need immediate support for food, shelter, healthcare, all of those needs. But they're also going to need long-term support to recover and rebuild in a way that is more resilient. And this kind of support is both financial support, but also technical assistance on, understanding how to make those improvements and how to get policies and programs in place that will facilitate it. Disaster preparedness, can certainly help improve outcomes in the immediate emergency phase after a disaster. But disaster mitigation in housing and in infrastructure ahead of time will actually help lead to substantial improvements in long-term recovery outcomes. And I think it's also important to note that these, preventative mitigation actions and programs, you really need to be targeted and accessible to those who are most vulnerable. Going back to your first question, is are making sure that these efforts do target the most vulnerable who will have the least ability to adapt and cope after a disaster.
Right. Now, what roles do policymakers and city planners have in helping to build disaster resilient homes and communities?
Yeah, well, I think that regulators, policymakers are making great progress on improving resilience and new construction through the evolution of codes and standards. Certainly, ASE has, of course, been a leader globally in that respect. And while I know work needs to continue along this front in terms of adoption, awareness, enforcement of improved standards, this is critical. I do think that there's a big implementation gap in terms of addressing existing housing. So existing housing that we know is physically vulnerable to the effects of extreme weather and other hazards. So putting together more policies, more programs that incentivize and provide support to addressing this need to increase resilience in existing housing, I think, is key. And improving existing housing is something we've studied a lot at Build Change. We have a couple of reports about some of the benefits. It's actually we've found less than a quarter of the cost to improve an existing house to be more resilient than to build a new one. It's also less taxing on the environment. So improving existing housing rather than building new reduces embodied carbon emissions quite significantly. We found around 60%. And it's also great to see that there are already some states that have programs, for home improvement, for improving housing resilience, which can be built upon and used as examples for other areas. Some of those are in South Carolina. There's a Safe Home program with insurance and financial incentives for increasing the wind resistance in housing. The California Earthquake Authority has a residential earthquake mitigation program. And there's more internationally. There are examples in Bogota, Colombia. We've been working with them on their home improvement program, and this improves both the structural resilience as well as the habitability of the home, and at the same time supports vertical expansion for safer urban densification. There's also home improvement programs at the national level in Colombia, in Indonesia, and in other countries. And these are really great examples because, as I mentioned before, they're also ones that are targeted at supporting those most in need. So those that are most likely the most vulnerable. So I think, putting more programs and more policies in place that incentivize these types of improvements is key.
Hmm. Well, that's good, and I'm glad there's seems to be a lot of templates that are worthy of emulation that others can look at.
Absolutely.
Now, how can civil engineers be a better support for resilient housing worldwide?
Yeah, that's a great question. And of course, I have to mention that they could certainly consider supporting our work at Build Change. We're a nonprofit, and we accept donations through our website, which is www.buildchange.org. But of course, there are many other ways getting involved in the implementation of codes and standards, advocating for policies that incentivize resilient housing practices, also through sharing knowledge, through participating in knowledge sharing events like conferences and sharing lessons learned from their own experience are also ways that people can get more involved to support resilient housing around the world.
Great, great. What was your website again?
Oh, it's www.buildchange.org. That's BUILDCHANGE. Build,
Okay, great.
yeah,
Thanks for sharing that.
yeah.
Well, worth checking out. Well, Lizzie, I thank you very much for being with us today for this important discussion we've had on disaster resilient housing.
Great. Well, thanks so much for having me. And we appreciate the shining the spotlight on this important topic for sure. Thank you.
Sure. I'm glad once again that you were with us. For more information on ASCE's Interchange series, visit asce.org/interchange. Thanks for tuning in today, and we'll see you next time on ASCE Interchange Live.